Good day, everyone, and welcome to our research discussions. Today, our group will be reviewing a fascinating study titled, which is a two-stage holistic model for road and rail intermodal freight transportations under demands and capacity uncertainties. My name is Chua Elaine, and I will be serving as the meeting chair to guide you all through our discussions and keep us on track. So let's move to the introduction parts. As this topic, this title was chosen for its clarity and precision, highlighting the article's main contributions, such as mathematical model designs to address uncertainties in both customer demands and rail transportation capacities, particularly in intermodal freight systems. We select these articles, and why we are going to select these articles, it is because these articles, it tackles a critical and timely issue in logistics and transportation management. As the freight volume increase globally, efficiencies and flexibles intermodal solutions are essentials for reducing operational costs and environment impacts. Moreover, this video aims to summarize the key aspects of the studies, including the models of two-stage decisions process and its use of conditional value at risk. In the short form is CVARs to manage the uncertainties and also to manage the risks. One of our relevant example is a logistic company transporting a containers from Johor to Kuala Lumpur using the combinations of truck and also rail. If customers' orders suddenly increase or if the train slots are unexpected full, the company must make a rapid, cost-effective adjustments to deal with this kind of the situations. In these study models, support those decisions by planning initial move and updating them as real-time data become available. By improving these decisions making under uncertainties, this research supports make resilient and sustainable freight transportation systems. Let's jump into the details. I will pass the floor to the Yixin, our research analysis, for the summaries parts.
Thanks, Elaine. As the team research analysis, my role is to analyze the core of the study for you. This study looks at how to improve intermodal freight transport using trucks and trains, which sounds simple but there are uncertainties to consider. The main research problem is the company often doesn't know what the customer demand will be ahead of time, or exactly how much capacity the train will carry. Since train schedules are fixed, that uncertainty can lead to wasted resources, higher costs, or delivery delays. To address this, the researchers designed a two-stage planning model. In the first stage, companies make initial container preparation and routing plans before knowing exact demand or train space. In the second stage, after real demand and capacity are revealed, those plans are adjusted. They are also using conditional value at risk to reduce the chances of very costly outcomes, and they add carbon emission limits to encourage greener operations. From real US freight data, the model shows several key findings. First, the model helps companies make better and flexible decisions under uncertainty. Second, being more cautious reduces big losses but may increase overall costs. Third, transportation costs were the largest part of total expenses, while penalties for emissions stay low. Last, increasing train capacity reduces the number of unmet deliveries, but adding too much capacity does not always lead to more savings. In conclusion, this model is practical for real transport operation because it helps companies to handle uncertainty, stick to train schedules, meet cost and emission goals. Now, Jia Yi, our sustainability advisor, will share why she agrees with the author's idea.
Thanks, Isins. As the group sustainability advisor, my focus is on the environmental and long-term visibility aspects of the research. After going through this journal, I strongly agree with the approaches and ideas presented by the authors. In my opinion, the model they propose is highly relevant to today's logistic challenges, especially when it comes to the managing unpredictable demand and limited transport capacities. In the real world, the logistic decisions often need to be made without knowing exactly how much demand will arise or how much space will be available on trains. The two-stage stochastic model suggested in the paper addresses that issue effectively by allowing the company to make initial container preparation plans and adjust those plans once actual conditions become clearer. I find these two steps decisions process very practical and realistic, especially in the context of intermodal freight where timing and coordination between route and rail are critical. I also agree with the author's decisions to include environmental sustainability in the model. Today, the companies are under pressure not only to cut costs but also to reduce their carbon emissions. By integrating the penalties for excess emissions and considering the carbon limits during the planning process, the model reflects real-world logistic priorities, especially for companies aiming to meet the sustainability goals. Furthermore, the use of conditional value at risk in the model is a smart choice. It allows the decision maker to avoid extreme losses, which is essential in a highly uncertain supply environment. I believe this kind of risk-based planning will become more common as logistics networks grow more complex and sensitive to disruptions. Overall, I fully support the directions and contribution of these journals. It balances the economic and environmental goals in a clear and measurable way, and it provides a solid framework that logistic managers and transport planners can apply in practice. The case study using the US freight routes further strengthens the paper practical value. I believe this model could be adapted to other countries or regions, including Malaysia, especially for companies looking to improve efficiencies while managing risk responsibly. In short, I also agree with the concept and methods proposed, and I see strong potential for this research to be applied in the real-world logistics system. There are still some improvements that can be made, and for that reason, I will pass it to our operation manager Yan Shans. Thank you.
Well, thanks, Jai. As the group operation manager, I look at the practicality and execution side of things. While I see the strengths, I do have a few concerns about the model's real-world applicability. Firstly, the model assumes fixed train schedule and predefined road routes connecting supply points to intermodal hubs. While this assumption simplifies the analysis, it limits the model flexibility, especially in dynamic or congested environments such as urban areas in developing countries. While the traffic congestion unpredictable delays and infrastructure disruption often require adaptable routing and scheduling. Incorporating dynamic routing decision alongside scheduling could offer more practical and robust solutions. Secondly, the use of condition value at risk is commendable in managing cost and emission uncertainties. However, the model risk considerations mainly focus on financial and environmental factors, without sufficiently addressing other practical uncertainties like infrastructure failures, labor shortage, or sudden regulatory change. Broadening the uncertainty scenarios considered would provide a more comprehensive risk management framework. Thirdly, emission penalties in the model act as a soft contracts, permitting accidents with associated costs. In reality, regulatory frameworks frequently impose strict emission limits that allow little or no tolerance for violations. This gap may affect the practicality and enforceability of the recommended logistics solution, particularly in regions with stringent environmental policy. And lastly, while the paper emphasizes cost reduction and emission control, it overlooks service quality dimensions such as delivery punctuality and customer satisfaction. So these aspects are critical for logistic operators, as failing to meet service level can have financial and reputation consequences, including the service performance metric would improve the model's relevance and ensure balanced decision making. In conclusion, although this study advances the integration of sustainability and uncertainty in intermodal freight transport modeling, its assumptions as limit scope could restrict its application in complex real-world environments. Future research should consider more flexible routing incorporate a wider array of disruption, enforce stricter environmental standards, and also integrate the service quality measurement. Now, Hilary, our strategy planning officer, will share our recommendation.
Thank you, Yanshan. As the strategy planning officer, my role is to connect the research insight into actionable strategy for companies. After truly analyzing the study and reflecting on its finding, we recommend that logistics involved in intermodal freight consider adopting two-stage stochastic planning models, particularly those that incorporate conditional value at risk. This model supports better decision-making under uncertainty, enabling companies to proactively manage unpredictable customer demand and limit train capacities. Companies should also begin integrating environmental sustainability into their transportation planning. As shown in this paper, incorporating emission penalties with logistic models encourage greener operational decisions without significantly increasing overall costs. Even small sustainability efforts can yield long-term cost benefit and regulatory compliance. For future development, we suggest that organizations collaborate with technology providers to implement such stochastic optimization models into real-time logistics systems. This could include using demand forecasting tools, real-time train capacity updates, and adaptive routing platforms to improve the flexibility and the efficiency of intermodal networks. Finally, we recommend that researchers and policymakers continue to refine and test such models in local contexts, such as Malaysia, where freight movement between road and rail is becoming more common. Customizing the model to local infrastructure, policy, and market conditions could help improve national supply chain resilience, reduce emissions, and also enhance service quality. In conclusion, applying this two-stage model can support a balanced, sustainable, and risk-aware approach to modern logistic operation. I will now pass it back to our meeting chair, Eileen, for the conclusion. Thank you.
In conclusions, we effectively address contemporary logistic challenges involving unpredictable demands and transport capacities. The proposed two-stage stochastic models enables companies to meet preliminary containers preparations plans and adjust them as conditions become clearer, which is particular for intermodal freight operations. Additionally, incorporating environment sustainability with penalties for excess emissions aligns to model with real-world logistic priorities. The use of CVARs enhance risk management in uncertain supply chain. Next, let's move to the improvements are needed for real-world applicable. Firstly, it assumes fixed train schedules and routes, limiting flexibilities in dynamic and also congested environments. Incorporating adaptable routing and scheduling is essential. Secondly, while the CVARs addresses financial and environmental uncertainties, it overlooks other particular risks like infrastructure failures or labor shortages. Thirdly, the model's emissions penalties are too lenient compared to the strict regulatory frameworks. Lastly, it negates service quality dimensions crucial for logistics. Move to the recommendations parts. The first recommendations it will be integrating environmental sustainables. It includes emissions penalties, promote greener operations without major cost increase, and also collaborations with technologies providers on real-time system is advised. Additionally, refining models in local contexts like Malaysians can enhance supply chain resilience, reduce emissions, and improve service qualities, also achieving a risk-aware logistic approach. So that's all for the conclusion parts. So thank you for joining us in this meeting discussions, and we hope our analysis provided both insights and inspirations for applying this concept in the real world operations. And bye bye.